everybody, welcome back to the channel. So today is part 2 of making our lathe drive dog. And for those of you that saw, if you didn't see our last episode, I'll leave a link for it below. But we got this far in making this drive dog. So what we're going to do today is we're going to carry a radius all the way up and around here. So we're going to be able to do up to here in this setup. Then we'll spin the whole thing around. We'll do the other end. We also have to drill it and tap a hole down in there. So we'll be doing that today as well. And making the little tang, the little stick that sticks out of here to actually drive the thing. I've got my compound rest set to 0. And I also have my cross slide set to 0. And I'm going to come along. You can see where I just touched this radius here. I'm going to come along with this radius. And when I get to this corner, I'm going to go past this corner just a wee bit, and then I'm going to use my compound rest to come out. So that's what I'm doing right now. So I've stopped nearly at the transition. I still have a little bit. I'm going to go a little more. But first, what I'm going to do, I already have a 0 on this, on the cross slide. I have a 0 set on my compound. I want a dial here so I can set another 0, so that if I want to increase or decrease this radius, then I'll have that as a reference point of where I started out and where I'm going. I'd say that's pretty much exactly at the transition point. Next 0 is her, that's right there. And I'm gonna come in 25 thou here and reset my 0. And we're good to go again. I am going to give this one more little pass just to bring this radius a little closer to this hole and a little closer over here. I just want a little more of that feature on here. Yeah, I'm happy with that. Now I'm going to carry this radius on, right on through this section here. And then we'll spin this part around, start working on the other end. I'm going to try and blend that right into there, just to make it kind of consistent. It's going to be by eye though. I have no way of knowing what it's going to take to get it there. So I'm just going to go a tiny little bit at a time until they line up, and then I'll make the pass. Oh, I probably went just a shade too far to get a perfect blend. Believe it or not, it's only 2.5 thou on my cross feed hand wheel. That's how much I went too far by, 2.5 thou. Anyways, it's close enough, and I don't care. Now we're going to dial off of, get these running 0, and then get these running 0. Trying my best for center height by eye. adjust it that little bit. Just go that way like a thou. See where these guys are at. I'm going to center drill this part. Not that I necessarily need all that support with my live center, because I'm not doing any heavy cutting and this is very well gripped in the forge jaw. But I am going to have to center drill it eventually, so I can drill and tap a hole right here. So I'm just going to go ahead and center drill it now, and that way I will have the added benefit of my tailstock in there while I'm cutting. Just taking a tiny little cut now, 2.5 thou per side. I think this will bring us to a nice blend, I hope, without overshooting it. We'll know in a minute here. Oh, it's pretty darn good. Probably still overshot it by like 1 thou. That was a 2.5 thou cut. And I think it overshot it by just a shade. One liquidifile, you'd never know. Yeah. Anyways, now we're gonna drill and tap this thing out. I'm just going to hit this with the countersink prior to tapping, and that way there'll be a lot nicer lead-in to this thread when all is said and done. The way I'm going to tap this hole is there's a center in the butt end of this tap. So I'm going to stick the tap in the hole. I'm going to have the tap handle resting somewhere on a flat surface up here, probably down here or something. I'm going to have my live center in here. And then I'm going to engage my split nut, and I'm going to set my quick change gearbox for 13 threads per inch. That way, as the tap handle travels forward, its carriage support will travel with it. So as I, crank the chuck around, the tap is going to advance in. I'm going to follow it here with the tailstock quill. Now I do want to break this chip before I go too far. the machine work is done on this piece. Everything's to size, maybe just a little cleanup afterwards. So I'm going to pull this out of here now. The next thing we're going to do is modify the end of this bolt. Right now it's really irregular and uneven. I want to make that perfectly flat so that when it presses in on a workpiece, it's a nice even surface that presses nice and evenly. And I'm also going to take a threading tool and I'm going to remove the threads for the first little bit here so that over time I expect the end of this will mushroom out, and I don't want that mushroom messing up my threads. So I'm just going to get rid of those threads so they can't get wrecked. So I got my bolt in there. It's not running true at all. That's as close as I could get it. With the hex head being stamped out, I mean, it's just not going to run true. Simply can't bear to watch this thing flopping around in there. Well, so I've got these little spacers. Oh, so much fun.
Can I hold something or something?
My tape's not even sticking properly. Well, it's there.
2 more to go.
Yeah, well, there we go. Now those will grab on the threads, which at least should run true to the other threads. And give us some bit of success here. Yeah, everybody's in the right spot. Let's see how she runs now.
That's way nicer.
Yeah, super happy with that. So I'm just gonna remove these threads and leave behind a nice 60-degree chamfer. There we go. That piece is done. Should be fine. Now we're going to move on to making the little tang or stick or whatever you want to call it that sticks out the side of the drive dog. Now we're going to make this drive lug. So it's got a 1/2 inch 13 thread that's 7/8 of an inch long here. And then I haven't shown this diameter, but it's going to be to suit the T-slots in my faceplate, and that's going to be 1 1/8 inch long. The order of operations here, this is just an old 5/8 bolt. That's what I'm making this pin out of. I'm holding it by the threaded end. I've got a lot sticking out, but I'm going to very gently tickle this end flat, and then I'm going to center drill it because there's too much sticking out to actually turn this down the way it is. I need it supported with a center. So I'm going to face it off, center drill it, get the center in there, turn down 2 diameters, my 0.450 for my tang or lug, and then a 1/2 inch diameter from there on for my 1/2 inch thread. Then I'll saw that off, spin it around, grab it by the small diameter, and cut that thread. I'm just putting a tiny center hole in here because I want as much meat possible on the end of this thing. That's what's going to be doing all the work. not very often that I use compressed air on my machines. I'm of the opinion that it blows stuff into places where you don't want it. But my one exception is to get the chips off of my lead screw. So I'm going to be engaging my thread chasing dial and my split nut to cut this thread. And I don't want to run all these chips through either of those things. So I'm going to get this spinning and I'm going to blow off the area of the lead screw where I plan to be using my split nut. Well, I am setting my compound rest to 29.5 degrees. Actually, I keep asking you guys if anyone knows why I do that. If you do, why don't you please say so down in the comments. I'm just setting the height of this cutting tool to center, and I'm using my height gauge to do that. In my machine, that's 0 right there. Let's see how we're looking over here. 5 thou low. Probably not the end of the world, but I'm going to fix it. There we go. Order of operations over here. I've already set my quick change gearbox up to cut 13 threads per inch. I'm going to engage my thread chasing dial with the lead screw. Going to rotate that up and lock it in place. Then I'm going to get it engaged at 0, and I'm going to rotate the chuck until I'm where I want to end my cut. And then, now different people thread differently on different machines at different times for different reasons. The way I do it is I set my 0 to be the outside diameter of the piece I'm threading. And I keep it there throughout the whole threading process. I do all my infeeding with my compound rest. And then I'll have my dial here like I so often do. I'll have it slightly under 100 thou. The table will contact the dial slightly less than 100 thou before I get to the end of my cut, and that'll be my 0. Then when I get to my 0, I'll simultaneously disengage the split nut and wind out my crossfeed hand wheel. And that way, instead of leaving a big groove at the end of my thread, it'll just blend out nicely every time. This is the exact point at which I want to pull out from my threading. I've got my crossfeed handle set at 0, and we're going to, in this dial, the table hits this dial just under 100 thou before we get to this point. Now I'm going to do all my infeeding from this point on with my compound rest. And you can't see it from there probably, but I have my thread chasing dial engaged at the 0. And I'm going to use the 0 for all these passes. On this first pass, I'm just going to take a little scrape and I'm going to check it with my thread pitch gauge. That's going too fast. Makes the end sketchy. Take one more cut at 5 thou deep, and then I'm going to start easing up on my cut depth.
Good?
It's like exceptionally good. It's tight, like when it's tight, it won't even fall.
Nice.
I'd go so far as to say it's mint.
Perfect.
I left this a little long. Now that I know where I've bottomed out with this thread, I'm measuring how much I want to face off the end of this thing. 80 thou.
That's a thread?
Well, I was just saying, it's so, the fit is so good, it's quite snug. Well, I'm gonna face off that extra 80 thou that I left on here. So final test fit before we Loctite it in, and I'm super happy with that. As these threads bottom out and tighten up, this is perfectly flush, and so now I'm going to Loctite it in there. So here's our finished drive dog. We've got our clamping bolt in there and our actual driving lug. So what I'm going to do now, I'm going to make a setup in the lathe. I'm not doing anything with this right now, but I'm going to make a little mock setup just so everybody can see this thing actually in position doing what it is it's supposed to do. I've got some arbors that I kind of neglected over the years, soaking in this used motor oil over here. And I needed my 1-inch arbor so I could demonstrate this to Drive Dog. So I had to go for it, had to plunge in there, grab it. So now I'm just waiting for it to drip dry.
Gross.
I'm gonna clean me and it up with this old sweater. And then we'll get this up in the lathe and we can do our little demonstration. It's dirty. There she is, doing her Drive Dog thing. So thanks for watching, everybody. That's it for today's video. I hope you guys enjoyed. And if you did, please consider liking, sharing, and subscribing. Bye for now. This poor thing's been soaking in used motor oil for a 1.5 years, and it's still just seized on there, something fierce. I really would like to use this again for stuff someday. Not quite sure what to do about that. If anyone has any tricks aside from heat, this is hardened and ground. I don't want to mess with bending it. So aside from heat, if anyone has any tricks on how to get these sleeves free from here, I'd be grateful to you.